So in terms of and now you can only be saying leftover, like lower team over. No, I have like a pair of shorts. You know, like one of them was this size and one will be like clothes. It's people
Okay, we're gonna get started. Welcome back to the Python decap. We're continuing our adventure with Astropy this week, and you'll be able to work with some actual data, which will be hopefully kind of fun. Yeah, okay, so let's get started. Pull up my notes. Okay, great. So homework 9 is due today. Homework 10 was released. I haven't sent out this Google form, but I will send it out at the end of class. We'll be hosting another round of review sessions, basically to wrap up the second half of the course. Well, more like we're basically almost done, which is kind of crazy already. But we'll host a review session to go over basically all of these new packages we've covered. So if there's something like you're like, hey, I really want to learn more about pandas, like let us know and we'll cover that. Cool. And then after, so I guess like our plan for the next few weeks, we'll do a review session. And then we will be doing, I think the week I find the most fun, you'll be learning about object-oriented programming, which is basically a style of programming that you'll see as you go and make more complicated programs. It's basically a way to really like separate out your code and be able to really easily change things. So it's really helpful, but kind of confusing the first time you learn it. And then you'll also be learning animations. So if you're doing that for your final project, that'll be super helpful. But yeah, so fun things to look forward to. And then we have like Thanksgiving, and then you have your presentations. So yeah, we're getting down to it. Okay, so with that, here is your warm-up. Take a few minutes. You'll need to use your computer for number 4, but try and do the rest on a piece of paper. So don't just Google things immediately, and then we'll come back together and work on them together.
there you go. It works, but then you just yeah, actually,
Okay. Do we still need more time? Raise your hand. Okay. Okay. Let's get started. So, okay. Great. All right. So, first question. How do you, let's go down so you can't see the answers. Um, how do you import the Astropy units in constants package? Does anyone remember? Yeah. Yeah. From astropy.units? Do you remember? Let me double check actually. I think it's, yeah, from Astropy, import units as you. Cool. Okay, great. Next question is how do I do the constants one? It's from Astropy, import constants as const. You can also technically, just for like future reference, you can also say import astropy dot units as you or import astropy dot constants as const. Doesn't matter how you it's doing the same thing, both of those lines of code. It's just your preference on what you prefer, how you prefer to import statements. So yeah, great. Okay, cool. So that's the first one. Oh, okay. I need to pip install astropy again. Okay, so pip install. Cool. Okay, that'll just take a sec. All right, great. Next question. How do you attach kilometers to the value 5? Does anyone remember? Yeah, great. U dot km. This attaches the unit km to 5. Great. Perfect. Okay. Then how do I change from 5 kilometers to 5,000 meters? Yep. Yeah, perfect. So I can attach this. I can basically say like x underscore meters equals x dot to u dot m, and then I can, if I wanted to, I could print it. So let's see what it looks like. Oh, sorry, it's pip installing it again. Huh, okay. Cool. Yep, 5,000 meters. Great, great. So yeah, in Astropy, we attach it by using this little extra package, and then you use .2 to just change the units. Great. Okay. Um, can someone, did you look up constants? What other constants does, you don't have to tell me all this information, but what other constants does Astropy offer? Did anyone look them up? Yeah, perfect. Gas constant, very helpful. Something else? Yeah, perfect. Planck length, something else? Perfect. Avogadro's number. Okay, two more. Yeah, perfect. We technically did that one last time, but counts. One more. Yeah. Oh, cool. Didn't know they had that. Luminosity of the sun. They also have the gravitational constant. So yeah, very helpful if you're just doing some physics simulations or anything and you just want to immediately have the constant there for you. Great, great. Okay, cool. Last question, and then we'll get started with today. How do you open a FITS file with Astropy? Does anyone remember? Hint. We'll use FITS. We can use with fits.open, and then you can plug in your data dot, I don't know, FITS file as HDual. I think that's the right. We'll cover it today. Let me double check. Remember it off the top of my head. Yeah, sorry. Yeah, with fits.open as HDual. Yep. And then we'd have like extra stuff going on. It's kind of weird. It's not the exact like pd.read CSV as it is with pandas. It's a bit different, but that's because AstroPy is cool and it lets you like import headers and your data. So those are the answers. It'll be posted later in the slides. But okay, so let's get started with some practice questions. So, cool. All right. Oh yes, I'll cover lecture. So, units with AstroPy. We just did that for the warm-up, but just to go over it again, I have a variable right here, and then that's basically like a container that holds something. I'm setting it equal to a number and a unit. And then I can set it equal to multiple units at the same time, and that's how it would print out. Very helpful if you're doing math that requires you to plug in numbers. Then we can also get valid. You can also do constants, and then you can get information out of them if you want a quick lookup table. But you can also use Google. And then yeah, we plotted this really cool, fun image. Gosh, gotta move this chair. We'll plot more images like that today, and we'll do some analysis on the images. So hopefully we have time for that. But yeah, super cool. Great. Okay, so let's start here. I'll give you a few minutes to work on this problem, and then we'll come back together and we'll tackle it. So here you go. Okay, how are we feeling? Thumbs up, ready to go over it. Thumbs down, I want to work on it some more. Thumbs down. Okay. Okay, so we have time to work with some actual data. I'm going to start going over this. Um, Feel free to ignore me if you just want to keep working on your own. Okay, so going back to my Jupyter notebook. So I ask you, pull up my notes. I ask you, okay, open a Jupyter notebook, done. Import units, constants, and matplotlib. So I'm just going to import matplotlib.pyplot as PLT. Cool. I should be doing this technically all at the top. That would be better, but we'll just do this for now. Okay, now I tell you to write a function called that calculates the ideal gas law. So I'm going to say define for starting my function. Then I'll say ideal gas law, and then I want parentheses, and then colon, and then return. This is basically the bare bones of my function. Then I'm told I want to use the arguments of number of moles, volume, and temperature. So there for one of my arguments, I will put number of moles. If you have no idea what any of this means, no worries. You'll learn about it in your physics classes, but this is a common equation used um, when talking about like pressure and statistical mechanics and stuff like that. So temperature, temp, temperature. Cool. So that's what I ask you to put in the arguments. So I have the name. I have my three arguments for my function. Make sure I have no errors. Cool. All right. So now I ask you to use Astropy constants and units and have it return the pressure. So I want to calculate the ideal gas law. And on the slide, I tell you that it's PV equals, what unit did I use? PV equals nRT. nRT. You might also see it written as PV equals K, KV underscore BT. Um, so just know there's also like a different constant here, but for now we'll just use this N. Okay, can't remember which one's lowercase, which one's uppercase, but it doesn't matter. Okay, so I'm going to start by defining the volume to make it easier. So basically my goal I told you is to end up with pressure. So if I rearrange this equation, that I want P equal to N divided by V. Oops, sorry. We'll do N divided by V times RT. So that's what I want this guy to turn into. So then I'm going to define pressure to be equal to N divided by V times R times T. So that's the bare bones, but I don't have an R up here, and I don't have a temperature or a T, and I also am told to use units. So I gotta expand upon this a bit. So for volume, I'll start there. So we'll do V equals volume, because I have volume right there, volume, and then I want to give it a unit. So I'm going to give it a unit of meters. So U times M, and then I want to cube that. because volume is given as a cubed unit. So you have like length, that's like meters. You have area, that's square meters. Then volume, like a cube, that's cubed meters. So those are the units I would use. And then for the gas constant, I would use R. And then as we talked about earlier, there's a constant, so const.R. Perfect. No more work needed there. Now I need to tackle this N guy. So for N, it's equal to the number of moles, and then I need to attach a unit. So I'll do U dot mole. So that's my unit for that guy. And then last but not least, I need to do my temperature. So temperature is equal to my value, and then I set it equal to U dot K. Okay, sorry. I know that was kind of fast, but those are the steps. So this is meters cubed. This is the gas constant, R. This is the number, well, moles. Moles is like, if you don't know what that is, it's like if you think of like a carton of eggs and you say a dozen, similar idea. Question, yes. Yes, you're very correct. Thank you. U dot M. Awesome. Cool. Number of moles, it's basically like the amount of stuff you have. Cool. And then temperature, that's in units of Kelvin. Kelvin is like akin to Celsius and Fahrenheit, just on a different scale. Okay, cool. Now I want pressure. Specifically, I want it in units of pascals. Weird unit for pressure, but it's common. So then U dot PA, and that's what I want. Okay. Do you guys want time to copy this down? Okay. Can I make it smaller to keep going? Okay. Gonna make that a little smaller. Okay. So now the last step is I ask you to, let's see, what numbers do I request? I say use N equals 100 moles. So I'll say ideal gas law. And then I want N, so number of moles equal to 100. Then I want my volume to be equal to 10. And then I say I want your temperature equal to 500. So then I hit enter. Hopefully I don't have an error. Oops, sorry. This is supposed to be temperature. Temperature. Cool. And that's my unit of pressure. So that's how you would use constants in a function. Maybe you'll use this in like a lab class, but that's just an example. Okay. Do you still want to copy this down? Or are we good to move on? Thumbs up if you're good to move on. Okay. Cool. Next question. Now you get to use some real data. So, all right, so under files, I uploaded a file called spitzerImage.fits. You may have to click the arrow to go to the next because like there's so many files in that one folder. But click it to go over to Spitzer, download Spitzer image.fits, and then save it in your directory in that same Jupyter notebook, and then open it up, follow these steps, and then we'll go through it together. So yeah, take a whack at it. Are we able to find the folder or the file? Thumbs up. Okay, cool. Yeah, so if you go under the folder in B courses, lectures, like slides or plus demos or whatever, you have to go to the bottom and click the arrow. There's some. Yeah, there's so many. Don't worry, I had the same problem. I uploaded it and I'm like, where did it go? And then and I tried to upload it again. It's like it's already uploaded. I'm like, you're lying to me. And I was like, oh, you have to click the arrow. Yeah. Are there any other questions about this problem you guys have? Nope. Okay. Okay, let's get started. Okay. So, we're stepping up the leagues. It's getting a little more difficult, so let's tackle this. All right, going back to my Jupyter notebook. So, you'll want the file in the same directory after you've downloaded it. So now we're going to import our file with Astropy since we have a fits file. Okay, so I'm going to use with fits.open, and then I'll do Spitzer image.fits. I'm pretty sure that's what I called it. As H dual. Cool. And then I ask you to save the data and the header. So to do that from last time, we create a new variable called header, and then I set it equal to hdual, and then I index it by 0, and then use dot header function. Then I also want the data, so then I do data equals hdual 0 dot data. Okay. I know this is really funky and doesn't make a lot of sense. That's just how you import data with Astropy. So we'll take a look at more of these in detail. So hopefully I don't have an error. Fits is not defined. Oops, I didn't import Astropy. Okay, so to import astropy.fits, I'm going to call from astropy.io import fits. Cool, there we go. So you're welcome to copy that down. You zoom out just a little. All right, so next step is I ask you to clean the data. If you've never heard that word before, it is kind of a weird word. It basically means that we have some things in our data that we don't want. So I want to get rid of all my NaN values. So when you download actual data from the internet for your guys' final projects, if you're doing that, sometimes your data will come as nans, which means like non-applicable, there's nothing there, and it can kind of really mess up your system when you try to process the data. So I just set everything to 0. So that's what we're doing when we call this this value. So we can also say, I think if we call, yeah, so we'll just go with that. All right. So I'm going to call data, and then I'm going to create a mask. If you remember our mask from last week, and then, I think I need to import NumPy. So let's import, maybe I don't, but np dot is nan and then data, and then equals to 0. Pretty sure I need to import numpy. Okay, cool. So this basically sets all of the nan values in my data to 0. Um, if do you want me to go in more detail about that? Would that be helpful? Or do you want me to keep going? Do you understand what we're doing right here? Be sure. Okay. Basically, we're just setting all our bad values to 0. Okay. Great. Next step I ask you is to print the observation date, print the exposure time, and the data shape. So when you get a file off the internet, you want to check to see what's in it. So this is basically a step you might go through if you're downloading data. So I'm going to, I already tell you the header values, but you can also print them. So I can say for key, so let's see, print header values in my data file, or my data file. So then I can call for key and header dot keys, and then I can print my key. So this is all of the names of the header files. You can see there's a lot of them. So I just tell you which ones to use. So we've got lots and lots of columns. So great. Don't want to do that again. So I'm going to comment that out. So then I say I want you to print the header of date. So let's see what the date one says. And I see it was 2006, December 2nd, at this time. So this is an actual astronomy image that was taken on December, or 2006 in December. So that's the date it was taken. Let's see how long the exposure time was. That basically means how long was the camera open to collect all of the light from the object. So let's see, header, we'll do exposure time. Cool. So 1.2 seconds. So not very long. Very, very fast image. And then I say I want you to print the, let's see, what else did I ask you? And then I say the data shape. So I'm going to print each of the axes. So there's 3 axes to my actual image. So then I'm going to print the header, and then I want to print an axis. And let's see what that gives me. And so I see I have 2 of those. So then I want to print my first axis and my second axis. So 1 and 2. Okay, so I'm going to slow down and repeat what I just said. That might have been confusing. So this right here tells you how big your image is dimensionally. So if you had a stackable image, that means you might have 3 axes. So this one might have been 3, but it's just 2. So that means we have an x-axis and we have a y-axis. So that's what the 2 means. Then this is telling you how many pixels wide the image is. So one side has 1,000 pixels, the other side has 500 pixels. Do you have any questions about that? Okay, well, hopefully that sinks in. You're welcome to ask me questions after. This is how this one image was set up. You might have to play around with your data. Okay, so, cool. All right, so that was for that question. So yeah, each of the n axes just mean the different axes of your image. Okay, cool. So now try and plot the image. I'll give you a few minutes to try that. Okay. I'm gonna start working on it. Um, all right. So first thing I say is I want you to plot the image with this figure size. Use origin.lower, and then use a color bar. So I'll explain what each of these mean as we go through. Okay. There we go. All right. So, cool. Now, I want to create a figure. So I'm now going to plot my Spitzer image. So I'm going to call plt.figure, and I said use a fig size of 10 and 5. So that's my figure. Now I want to plot my data. So I'm going to call plt.imshow, and I'm going to say data, and then I told you to use origin lower. I'll first show you what it does if you don't use origin lower. So I'm going to run this, zoom out of it. Here's my image. You can see there's some speckles in here. You might not be able to see in the back with the lights on. Sorry about that. But not all images will adjust it to be the origin at 0. See how it says 500? And then it's 0 up here. So that's kind of funky. It's not what we're used to. So then I'm just going to put origin at lower. Origin equals lower. And this basically just sets the bottom left hand corner to 0, 0 as your origin. Okay, so let's take a look now. So I'm zooming out. Oh, yep, there we go. So now the zeros are both in the left-hand bottom corner. Great. Okay, so going back to my code, then I ask you to add a color bar. So then I'm going to say plt.colorbar. Run that. Let's take a look. There we go. It just automatically defaults to using this like Viridis color set. You really can't see anything with the lights on. No, okay, I don't know. I pressed some buttons and didn't do anything. So sorry about that. But hopefully you can see it on your computer. And then if you wanted to like shrink your color bar and make it to fit better, we could then do shrink equals 0.8 and then plt dot show as always. Cool. Okay. Spelled shrink wrong. Shrink. Okay. Cool. Gonna run that. Zooming out. Here we go. My color bars. Now the size is my image. You really can't see it, but there's like a speck right here. Hopefully you can see that. We're looking at stars. Really cool. Okay. Great. Now the next thing I ask you to do is to make a histogram of pixel intensity. So I want to figure out how many pixels are really bright, because that'll tell me like the distribution of not how many stars I have, but it's a helpful metric to know. So we will do, let's see, and I say to use bins of 50. So then I will do, zooming in, oop, too far. I will do plt.hist, and then I will do, I don't know if I want to use bins.50. Okay. Okay. Instead, I'm instead going to use, I'm just going to skip to the next one. So in order to basically lay out the intensity of all of my pixels, I need to plot them. I basically need to take my 2D image and turn it into a 1D thing. So to do that, I'm going to call data.ravel. I'm going to set the bins the bins to be widths of 100, and then I want the range of my data to be between 100 and 4,000. You would figure out this range by looking at how the brightness of your pixels, but in this case, I just tell it for you. So this is going to give us a histogram, and let me zoom out. Whoop. There we go. Cool. So this is a histogram of my pixel intensities. So I see that I have a lot are really close to a really bright value, and then they start to die off as I get closer to the dark background. So yeah, cool. Okay. Sorry, I meant this to be 100. Looked a little funky. Okay, 100. Cool. So there is my histogram value. So I have a lot that are really, really dark, and then I have just a few that are bright. Sorry, I said it backwards. So yeah, these are our stars way out here, and this is basically our entire dark background. So yeah, that's helpful if you go and take like optical lab. They'll make you do stuff like this, and you'll use it to basically do something called cleaning images. We're not going to get into that details, but just helpful to know that when you work with images, you'll want to plot them as histograms for pixel intensities. Okay, great. I'm just going to do a little bit more fun stuff you can do with Astropy, and then because we don't have really time to go over any more questions. Okay, so when you plot images, we talked about doing the log norm last time. You can also physically determine where you want those bins to be. So I'm going to create a parameter called vmin, and I'll set it equal to 100. And then I'm going to create a parameter called vmax equal to 1000. So basically, in the histogram plot, I had values ranging from 100 in the brightness of the pixel to 4000. But I don't want that big of a range because a lot of those are outliers and it's not very helpful. So I'm going to really make a much smaller range, and then I'm going to replot my image. So I'm just going to go up here. I'm going to copy this again. So copy that. Come down here. But now for my inside of my image, I'm going to set how bright I want the smallest pixel to be and how bright I want the brightest pixel to be. So that's what these parameters are doing. And then I'm going to run this and I get way more stars. You can really see it on my computer, but you get way more dots on this image compared to this image. So therefore, we're only really plotting the middle values. We're getting rid of all of the outliers. So this might be helpful for you if you're working with actual images in your final project. Cool. Okay, so gonna keep going. You can also stretch the image, like we talked about the log norm. So we'll do that again. So scrolling down, you can actually do it with Astropy. So I'm going to call from astropy.visualization import simple norm. So I'm plotting it on a log normal scale. So I'm going to go up here. I'll copy my statements again, come back down. And then I'm going to, instead of using these parameters, I'm going to block that out. I'm instead going to use something called norm. So I'm going to say, sorry, stretch is equal to square root. You'll see what I mean when I plot the color bar. And then I will put, oops, sorry, that's wrong. It is norm. My bad. It's norm equals norm. And then I'm going to create a variable called norm, use the Astropy function, plug in data, and then my stretch equals square root. Cool. And then I'm going to plot my color bar, and then I'm going to run this. Cool. Okay, it's really sad that you can't see this very well. But basically you get out way, way more stars in this image than you do even the previous one. So I'll scroll back up so you can copy it. Well, first I just want to point out one thing. If you look at this color bar, it's plotted on a log scale. So there's really big gaps between the really dark stuff and the really bright stuff. So you can really make out the fainter stars. Whereas on the other color bars, you had evenly spaced brightness values. So it's really hard to tell the difference between your background image and the stars you were looking at. So yeah, that's a little bit of data processing that you can do with Astropy. I apologize if that was fast. It's really hard to teach image processing in an hour. So yeah, okay. Are there any questions about what we did today? Okay, I'll post the demo if you want to go through it again. But yeah, you'll have more practice on your homework. So yeah, okay. I posted the engagement, so you're welcome to work on that for the rest of the time. Hey.
But it looks like half the class didn't even like read it.
Yeah, just give them zeros.
Gotcha.
A lot of them are also know that it's not due till December. So,
Okay,
and then yeah, we're also passing a pass class. So
that's right.
yeah, but no, give them zeros because then it shows up in the grade book. So
For sure.
yeah, no problem. Question?
I'm just curious for this homework.
Yeah,
I'm sorry, I had midterms this week.
you're so chill. I
well,
totally get it. Totally.
I'm trying to like pull the the data for the
Yeah, totally.
thing,
Mm-hmm.
and I've like tried a bunch of different stuff, but it keeps coming up with like already up.
Yeah, can I take a look?
Yeah. Thank you.
Oh wait, you're on your own. Okay, so you want to be on course.
I remember that.
Okay, so it looks like you're in your directory. And then if I CD out of here. That would be closest.
Yeah. They want to take it, so it's all stable.
That's fine.
That's fine.
Right. Okay, maybe that's, yeah, that's fine. That's probably yours, yeah, well, at least we know the problem. Okay, let's see the again. Yeah, that's your phone.
Yeah. Oh, yeah.
How are you?
Yeah, we're my like main, I think it was in my main branch, my main.
Yeah, that's your phone.
And that's been an issue because like it's trying to leave, but it doesn't work.
Yeah, so basically there's supposed to be two separate things, because they're basically both like they're both folders that can change a lot with like the internet, like we have internet version. So combining them together, GitHub just gets confused. So what you'll want to do is first one thing you want to do for like a walkthrough inside of Python. Yeah, inside of the folder. You can just like done like the git one, if you go back to homework too, really put it like that. Yeah.
Sorry.
I'll find you guys the national. Okay. Yeah, I was just wondering what the min and max parameter.
Yeah, totally. So, remember that pixel distribution I showed, or the histogram?
Yeah.
Yeah. So essentially, you have like it looks like this, and it like dies off. And so this was 0, and this was like 5,000. Essentially, everything like past here, and then like before here, these are like outliers. You don't want them in the data. Then we're just plotting this range right here. So basically like anything that's 0, we're just setting it to 100. Or anything below that, we're just like moving it to 100 or moving everything down to 5,000. So it makes it easier for us to see what's going on the inside.
Is it like you're like restricting your access, or is it like you're like fitting the data inside of that range?
Yeah, so you're basically just you're not changing the data, but
Okay.
you are a little, but like you're essentially just saying like on my image, like if a value is like 4, if like this is the actual brightness, it's just capping it at 4,000.
Gotcha. So you're only looking at it within that range.
Yeah, exactly. Yeah.
Okay. That
Yeah,
makes sense.
it's weird, but it's a technique for image processing, so yeah.
Cool.
Does that make sense?
Yeah.
Okay, good.
Thanks so much.
No problem.
Okay. Really?
Yes, you still on that? Do you need like? So they go to code. And then they put this or something. Yep, and then these up. Great, and then can you see these into that big copy? Yeah. And then homework 7, then try and CD into that folder. Thank you.
This might be why I've been having so many issues.
Yeah, I
'Cause I've
think
been,
that's
like-
probably why.
I've been going through like crazy channels to get.
I'm impressed we made it this far with putting it in that repository. I'm very impressed, really. But hopefully that should make things easier for you.
Yeah. Okay. This is amazing.
Okay, good.
So now I
So LS.
have to
Yeah,
get the.
Yeah. and then just move that, copy that into your Nolan, homework 7.
Okay. Wow. I didn't really think I'd find out. This is great. Okay,
Yeah,
thank
okay,
you.
no
Thank
problem.
you so much. I appreciate it.
Yeah, totally.